Good day, everyone around the world. Yeah, some kind of disappointment. I'm not quite happy today. You know what? I don't usually fix same problem twice. It's some kind of rare, like fixing a laptop. 2 3 days, the customer came back. So you remember our last upload on YouTube, our last repair. If you do remember, our last Toshiba Satellite Pro C850. Uh, I fixed the laptop. I checked everything was fine. I tested everything. You remember when we opened the laptop, there was a shorted MOSFET. After that, the main 19 volts power line was shorted. I checked. I come with the power supply. Nothing was getting hot. I checked with the finger. I found, oh, the CPU is taking that power. And that was a capacitor on the vehicle section. And I replaced the laptop, worked fine. But the problem is the laptop worked just for a day. And the customer came back with a dead laptop. I opened the laptop, same issue. If you do remember, where's that? This one. If you do remember this laptop, Toshiba Satellite Pro. If you do remember, I started this job. That was like a dirty Toshiba Satellite Pro C850. I opened the laptop. I checked everything inside. And when I checked here, the fuse was good. You see this fuse with the letter Q on top? That was the fuse which was connected on the plus of the charging port. And after there was an inductor here, a black inductor. After the inductor, we have a fuse which was good. After that, we have this first MOSFET, which is N-channel MOSFET, was shorted from drain to source, and also from gate to source. From gate to source was a short. From source to drain was also a short, but the short was not like a short to ground. That was the dead MOSFET by itself. So we replaced this MOSFET, and after that, what we did here, check here, you see this capacitor. I was coming with power, and the capacitor was drying. And the capacitor was drying, this one, which was on the vehicle section. We replaced the capacitor and the laptop worked. And the laptop worked. So I want to clear out some of the mistakes which I done on that video. I don't usually do like fixing one job twice, but let me draw something. Let me draw something here, and let me draw something on desktop, and then we'll analyze together. So what we have, on that laptop was like this. We have the DC in here. That's the DC in. Here. And on the DC in, there was an inductor. an inductor here. That was an inductor. After the inductor, was a fuse. Exactly here. After the fuse, we found two MOSFET in serial mode. M to the power 1 and M to the power 2. Those were N-channel MOSFETs. 4 pins together, which is drain, and we have 3 pins together. We have another 3 pins together here. They are connected together. And here, we have 4 pins together on the output. After that, there was a current sensor, current resistor, very low ohms resistor, below 10 ohms. So, we checked here, this MOSFET, the first one was shorted from drain to source, and also from gate. Here we have 2 pins here. The gate is coming here. That's the gate, which is coming to some kind of BQ chip. BQ, which we didn't check there. We don't care about this BQ chip. But I want to go. I started with the problem. I started from the input so that you understand. Here is the DC in for 19 volts. That's the plus. The plus is coming from here. The minus is going to ground. We don't care. That was a Toshiba laptop. We have 2 wires. 2 wires on the plus and 2 wires which are going on the ground. So that's the ground. And on most of the laptop, next to the charging port here, you found what do you call it? In most cases, you found the wall sensor there. Magnetic sensor. When you close and open the laptop, it will sense for the laptop to shut down the screen. And this wall sensor is also communicated with the E.C chip. So on the wall sensor, we have 3 pins. The one which is going to ground again, and this one, that's the VCC in, and that's the VCC out. Next to the charging port, there was a wall sensor there. So after the current sensor, the voltage is going to all the power supplies on motherboard. But we are concerned about the 1 volt for the processor. Because here there was some ceramic capacitors which were connected to ground. I don't know how many were there. After that, some MOSFET. This one, which is connected to 19, 4 pins together. And we have 3 pins here. And we have 3 pins here. And here, the gate is going to the BQ chip. No, the gate is not going to the BQ chip, sorry. Here is an independent switching power supply. The gates of these MOSFETs, they are going to, those are some kind of old laptop motherboards. Maybe we have the ISL. Or any kind of chip which is the controller of this switching power supply. And the vehicle section next, there was also another one here. Ceramic capacitors. Another one, ceramic capacitors. And after ceramic capacitors, 2 MOSFETs. Same here. And Three pins together. The gate is going to this chip, and the gate of here is going to this chip again. All the gates of those four MOSFETs, because the reason why we call the vehicle section, we have two coils there, four MOSFETs and the driver. Okay? So our problem is here we have two coils. Two coils here. And on the output, there was electrolyte capacitors. Like three of them. Those were electrolyte capacitors. And here, that's the 1 volts for the processor. So these capacitors, they were in short. We found one capacitor which was in short. Here, one capacitor was in short, and no one asked on the channel why the output capacitor on the processor power supply was shorted, and all the MOSFETs were still good. No one asked me about that. So we overlooked the situation. This output capacitor, which is meant to work with very low resistance and very low voltage, around 0.9 maybe to 1.2, 1.3 volts. The capacitor was shorted. And I came back, I replaced this capacitor, like 2-3 capacitors, they were getting short. The electrolyte one, if you do remember here, this one, if you remember this one, I replaced so many times, like 2-3, and the capacitor was still getting short easily. And what was the problem? The problem was this MOSFET was partially shorted and was sending straight 19 volts to the CPU. That was the mistake that we did on that video. The upper side MOSFET was shorted, not like short, but was partially shorted and was sending all the 19 volts to the CPU. When I touched with my finger, the CPU was getting hot because the upper side MOSFET was shorted. At first, we didn't replace it, but the laptop worked for about less than 24 hours. The customer came back again. We replaced this, so our problem was this. This MOSFET was partially shorted. We replaced this MOSFET and the laptop was working fine. This was sending all the voltage straight from the VCC here, going this to the processor. So that was the story about that Toshiba repair. I was very disappointed because usually I'm fixing gadgets once and they go. I don't have like too many coming back complaints on repairs. So yeah, that's the story basically about how the old laptop motherboards they are working. Two MOSFETs, current sensor, the voltage is going everywhere. Also from here, from this current sensor, let me use different color, red or green. From this current sensor is managing so many voltages. We have 5 volts, which is going to the USB. We do have 1.5, that's the RAM voltage. We have 3.3, which is going to the E.T.C chip. We have the 5 volts power supply, the 1.5, the 3.3, which is also giving voltage to the E.T.C chip, the embedded controller from the VREC 3, which is always on. Also, this VCC, we do have like 0.9 volts, that's the GPU voltage. The EPU voltage. We have maybe another 3.3 separate for the PCH, depending with the schematics. So that was the story. I made this video because if you face some problem, maybe you are going to have complaints, like coming back complaints, the laptop will die back soon. Why? Because this MOSFET, you have to check these MOSFETs for the vehicle. In most cases, the upper side MOSFET, the one which is connected to the 19 volts, not this one which is going to the ground, the upper side MOSFET will be shorted and will be sending 19 volts to the straight to the CPU. And this is a lucky customer because this CPU was supposed to die instantly. But for some reasons which I don't know, the CPU was still alive. So, yeah, that was the story. That was the story about that Toshiba repair. That was the story. So now that the Toshiba, after we have replaced the MOSFET, maybe for the sake of interest, we can retest again. Maybe, who knows, maybe it's no longer working again. But I swear, that was the problem. That was the problem. Where is the charging port? This side. Let's just test for the sake of interest. On 1 amp Toshiba, and the laptop is working fine. It's loading Windows. It's working fine. There are no issues there. As you can see, the laptop is working fine, as you can see. So that was the story about my mistake. I overlooked the reason why the output capacitor, which is meant to supply around 1 volt or 1 point something volt to the processor, how can that capacitor die when all the MOSFETs, they are still good? Actually, the MOSFET died before that capacitor and was partially shorted and was sending too much voltage to the CPU. So like, subscribe, don't forget to turn on the notification bell for future updates. Also, share our videos to everyone around the world, and see you on the next one. Bye.